So the exhibition here actually traces the development of the periodic table, because of course this year is the 150th anniversary of the publication of Mendeleev's first periodic table. So one of the items that we have on display is Mendeleev's first published periodic table. We have that in his first textbook. So this was initially just added in the front of his textbook, but we also have the first journal version as well, which was a much larger article, longer article about the periodic law. But also in the exhibition, and I think in many ways even more exciting, we have some of the earlier forms of the periodic table, including the very, very first attempt at creating a periodic table, which is the so-called telluric screw of the French mineralogist known as Alexandre-Émile Beguier de Chancourtois. And this is really quite stunning. So this is the first arrangement of the elements in order of their atomic weights, and looking for the repeating patterns of the periodicity that we all know. Now he planned that this should be in the form of a cylinder, and so we've also reconstructed one of these cylinders on display next to this original publication. But the publication is incredibly rare because it is over 5 foot long, and they didn't include it with the original journal article of his account of this classification, and so it was completely overlooked. It was only present in the off-prints that he circulated to some of the scientists of the day. So it is now very, very rare and was overlooked at the time, but this was 7 years before Mendeleev's first periodic table. So we start actually with the first delightful picture from a book from the 17th century showing the 7 metals that were known at the time, and antimony, together with antimony. And these are charming little woodcuts. But of course, at this period, this is in the 17th century, it was not appreciated what an element was, and it was thought that the metals were actually compounds themselves. So in a sense, modern chemistry starts with the realization of what an element is, something that could not be broken down into any simpler components. And this really we take to begin with Lavoisier's first list of chemical elements. And so this is on display in his original treatise. And then we move on from there through Dalton with his atomic theory and his first list of atomic weights. And this is quite a milestone again. So these were all relative to hydrogen, but the only one that was correct is sort of hydrogen, and this is because of his assumption that when chemical elements combined, they would combine in the simplest proportions. So he thought that water had the formula HO, essentially in our modern terms, and this meant, of course, that the mass, he knew the combining proportions of hydrogen and oxygen with some experimental error, but because he assumed one atom of hydrogen combined with one atom of oxygen, it meant that the mass of oxygen was now a half of what we would take it to be. So this is quite interesting. This is a real struggle, actually, that you couldn't really get a good periodic table until there were enough elements to spot the patterns, but also there were a reliable set of atomic weights. And so this is then a balance, and this is one of the things that's explored in this exhibit, what was needed in order to come up with a periodic table. Well, this is interesting, and we have on display the first account in English of Mendeleev's arrangement, and this is probably picked up from the German account of his original article. And it simply says Mr. Mendeleev has arranged, has a new order of elements, and they list the first 8 or so, and just say etc. So I don't know how anyone could understand a list of a form of a periodic table from the first 8. And also there's an error in that they put Fe instead of F for fluorine. And so I think this highlights that it wasn't taken seriously, that when his law first came out, nobody really, well, I think people paid more attention than with some of the earlier versions, and actually it's very interesting to see how Mendeleev's first table compares with that of the Englishman William Odling that appeared 5 years earlier, and the tables are really very, very similar. And of course there was also the English chemist John Newlands who published his version of tables. But I think the real reason why Mendeleev drew so much attention later was because of his very accurate predictions of some of the missing elements. And so, for instance, when gallium was first discovered, a few years after his periodic table, then people really paid attention because his predictions were so close to the observed properties of gallium and its compounds. And that was, I think, what made people really draw attention to his system, his periodic law, and it sort of validated it at that point. I think it's terribly exciting to be, for me at least, as a chemist, to be celebrating the International Year of the Periodic Table. But I think it's also important for people to try to get a little understanding of the science behind the world that we live in. And of course, I mean, before the periodic table, there were many attempts to group the elements into ways that made them make sense. I mean, there are, after all, quite a few elements. We might not come across all 118 in our everyday lives, but it is good when we're trying to learn about these elements to see that there are ways that we can understand how it all makes sense, how elements can have similar properties with each other. And this is the beauty of the periodic table, and I think it's really exciting to try to explain this beauty to as many people as possible. Well, I think it is... I think often, actually, of course, chemistry still has this slightly negative... people have a negative impression of chemistry in the general public. They think sort of nasty, evil chemicals. In fact, even with this exhibition here, I'm showing some things, and they are unpleasant, but people don't make this assumption with the world around them. So, I mean, even we have a nice glass jar of chlorine on display, all sealed up, perfectly safe. But people think, oh, this is terrible. And I say, well, but you have bleach at home, don't you? And they don't sort of tie the two things together. And it's good to make people aware of how chemistry fits into their everyday lives.